Hello and welcome. My name is Oskar Kaplun. I'm working at CANopen Automation, and today I would make a brief introduction into CANopen technology we use in particularly for the lift applications. So as you can see from this picture, there is already CANopen Lift installed, a network installed in Berlin main railway station. It's just to give you a hint where CANopen can be used. And this is, of course, today's topic, CANopen Lift. So my presentation, introduction for CANopen will be related more or less to the CANopen Lift itself. So a few words about myself. I'm electrical engineer and I'm working at CANopen Automation for about 10 years. Give it a take. I'm supervising multiple technical groups, support the groups to develop specifications, and beside that, I'm supervising also the group for lift control. So 417 specification is currently developed together with the engineers, and I'm looking into that CANopen part is correct in there. Beside that, I'm doing testing at CANopen Automation and so on. So much about me. I would just like to give you a brief overview of what we're talking about today. Short introduction to CANopen communication model, ISO-OSI. What are the lower layers of CANopen? How do we handle them? Then basic concepts of CANopen, which are also, of course, used in generic devices or particular devices, and also in CANopen Lift as well. And how do you design the lower layer, in particularly also related to the lift application? I'll go through the basic lift protocols, basic CANopen protocols, advanced protocols, which are used as well in a lift, but they could be used in other applications. But the lift is our topic of today, and give you a hint, what is this device and application profiles? How do you handle them? What is this all about? For the starters, some history. CANopen was designed initially for use in industrial automation, but first it started with a scientific project from the university where everything was covered by that time necessary, and later it was adapted for industrial needs, like 8-bit microcontroller, which could handle very small things relatively up to now with 32-bit microcontrollers and CAN controllers handling practically everything else. Of course, CAN Automation took a big part in it. It supervised and followed up with all the development in CANopen in there. There are some companies providing off-shelf tools for CANopen development, protocol stacks, also devices, of course, and application, the whole application and systems connected through the CANopen network. So we define them. One of the important thing is CANopen Lift. It is already about 20 years old as specification, and the developments going on still up to now. We introduce new functions, maintain, improve functionality in there. That is basically it. But beside CANopen, we have CAN-based further technologies like CANFT and CANXL. This is upcoming one, and we adopt CANopen to these new technologies. Few examples of CANopen usage in there. This is silicon wafers used for manufacturing microcontrollers, microprocessors as well. It's located in Dresden. and it is used in a process of manufacturing CANopen in downscaled and deep embedded CANopen network. So as you can see, machine module 1 and 2 or up to n modules, their modular structure CANopen allows to do so. This is pretty effective one, and it is controlled using TCP/IP from the remote monitoring station. Now, of course, we have lift application. This is Railway Main Station Berlin's used one and designed over times ago. CANopen is also used in Airbus internal network and some other examples in hotel and in a church. So beside that, of course, the total overview of various CANopen markets. It started all in industrial automation, embedded control systems, and go up in various directions. And literally, CANopen is used on a sea, subsea level, in a space, in a sky, and on Earth. Railway vehicles, maritime electronics, aircraft, cranes, construction machinery, power generation, medical device application, building controls, whatever you name it. And this grows, the market of CANopen still grows. I have not enough place to put all the markets we actually could have and have in there, but I think this will be sufficient overview on this. So if you are not in CANopen Lift or at CANopen at the starters and you don't actually know more about this, so you need to think about this. What should you use it and what are the reasons to use it, if any? So the most advantages of CANopen come from the CAN data link layer. CAN is very effectively used, flexible, and data consistent and reliable network, area network protocol, and the messages transmitted in there gone in a very short time. There is only 8 bytes of data, very effective way to transmit them in broadcast as producer-consumer model, communication model. They're robust and flexible and have very effective error monitoring, error control in the CAN network. These are the most advantages CANopen takes from down-layered CAN data link layer. And itself, CANopen offers the data itself, and the data is open. This is where high degree of compatibility comes inside. So the data is actually known to everybody. If you design lift application, you could actually take off-the-shelf devices, connect this into your network. It should work in general. So the specification for that is even public. Of course, we have further developed specification available only for our members, but non-members could start also to design it with a publicly available specification where all the data actually known where it is located and how you handle that. So again, there are several providers of software, protocol stacks, hardware design, device design, system design tools. This is where you know only few of those and you contact only those and don't have to choose between thousands of developers of such tools. There is also a kind of advantage in this case, so you don't need to look much around it. So the technology in general, not CANopen Lift itself, but CANopen is partially approved, especially for CANopen safety and standardized. Actually, basic CANopen protocols are standardized in there. This gives you a very high degree of compatibility of devices you purchased if they are designed according to the standards and so on. CANopen Lift is not standardized. The group itself is just thinking about this idea, but we are not yet there. So So far about this general introduction. Now we can open to the basic concepts of CANopen, which are actually applied to every CANopen device or application, such as lift application. But we speak about lift application in particular. So this one you can see is a communication model according to ISO-OSI. We have three layers only: data link layer, physical layer of CAN, and finally, since we don't have a human being operating and checking all the data, this all done actually machine-to-machine communication, actually in the device, especially in deep embedded networks. So we need only three layers, and CANopen is the layer 7. And in this layer, we have standardized data communication, which is actually represented here as the so-called CANopen communication object. So this data, which is actually transmitted using a data link layer in a CAN frames, is specifically designed, and to make it advantages are more optimized and very optimized. CANopen is used in this case down layered CAN data link layer and physical layer. So from these layers, the most advantages of the CANcom and CANopen comes, and it shall be actually using the all and we optimized up to this data link layer and physical layer to achieve the more effective communication efficiency. So we talk about a couple of layers, the physical and data link layer, to give you some overview what is actually the advantage in there. As you can see, the physical layer is not some kind of one, but the standardized one in ISO 11898-2, physical medium attachment. For having the physical parameters to adjust there, we have and cabling, we have specifications designed, especially it goes for the lift. In this slide, you can see the typical topology, typically CANopen topology applies to any CANopen device. This effectivity of the device layers between in the line topology. It is close terminated with two termination termination resistors, and totally we have 127 devices. So the lift network is built again like this. The bus line itself is a differential twisted wire pair, which may require additional third line as a ground to assure that all the signals, the differential signal, lays on the same ground. If there is not the case and all devices lays on the same ground by default in there and it can be assured, you don't need a third line as CAN ground in there, and could use your differential bus line with only two wires in there. So for knowing how to design the system, the line and topology itself, there is a 301 bit timing table which illustrates additionally the length of cables and total length of cables coming from the device to the bus line, and there are the values which shall not be exceeded in this case. I've marked this in another color, in a blue color, to let you know that there is referred to the very specific, bit rates used only in this case. For the lift, it is 125 kilobits per second and 250 kilobits per second. You could remember this number if you're not in a lift yet, but this is good to know in there. So for the data link layer, we use also standardized one. Standardized data link layer and physical signaling in there. And for the signal itself, we use truly the bit timing. And you see the same slide, and you can find out where it is actually located in principle there. For each of these bit rates available for Lift and also for the other CANopen devices, you have the very exact constraints where you have to choose and how to configure your CAN controller for use in CANopen and in CANopen Lift components design especially. So for the CANopen data link layer, CANopen uses the communications from the CAN, which is actually producer consumer, transmits the messages in broadcast. And there is a possibility to do this also remote frames to call this data, like you see in broadcast, but you use remote calling there. So it is not recommended due to some known flaws, but there is no reason to avoid it if you need it. You just have to get know to why it is so, and that is where you could contact us in more details to know why it can be happen. So don't recommend it, so that should be data submitted in producer consumer. So that is not CANopen typical, this is just what CANopen uses as getting the data. So now we talk about internal device structure. It consists of the three parts where you have CANopen protocol stack. On the other hand, you have your Lift application or whatever device application in CANopen you have, your software routines, I/O modules, buttons, inverter, and application software for that. And the object dictionary in the middle contains all the CANopen parameter you required for configuration, for exchange, for application, and it goes both ways between the protocol stack and goes to the network to the other devices, or it goes from the network into the application where it is processed. The object dictionary is important part. There is a certain structure. We call them parameters, indexes, and you store their communication parameters for configuration, application parameters, which is called their standardized profile area. And you could design your own parameters in the manufacturer specific profile area. There are few parameters which is mandatory in all devices, especially also for Lift application, which you have to anyways have in there. I just wanted to point you out because my colleague will talk about one or two of these parameters in there in his presentation of the Lift specification. So this device type object gives you information not only about the profile, but also about the very specific device type you use. This is used in special ways in CANopen Lift. Another one is the state machine indicator, actually the only one bit of this byte object 1000 is indicating if the device is in error condition or not. And other additional bits can be used to indicate more exact reason for the malfunction in the network. Another important object is the identity object. It is used in several services of CAN automation, CAN automation, and in CANopen especially. For layer setting services, we'll talk about them later. And the vendor ID is the subindex 1 is mandatory, and it is assigned by CAN automation. Without it, the devices actually doesn't officially exist. There is, of course, predefined connection set applied for every CANopen devices, but not for application profiles. It just gives prepared overview. How can I configure my devices and where are the parameters where I could perform configuration? For the Lift, there is another set derived from this one, but it's just good to know that a standardized way to find how do I do define my CAN identifier in my CANopen Lift or CANopen in general network. Now we come to the basic CANopen protocols. There will be several ones. We have first transport protocols, and CANopen allows also network management. For transport protocols, we use effectively producer-consumer model. So we transmit the process data in broadcast. This is called in CANopen process data object. It is more advanced than that. It allows to define parameters, which parameters should be mapped into the CAN message itself. And it is used for pure and very effective one message broadcast of process data. Service data object SDO, there are three kinds of it, used mostly for configuration diagnostic property reasons, but can also be used for the process data. Especially in Lift, it is used for configuration. And there are three protocols used in there, three kinds of protocols. One is very simple, very effective for transmitting maximum 32-bit of data. If you need to download software in the bootloader or download the firmware over the bootloader into your component to make it do some things and performing some functionality, you could use segmented or block transfer, which is allowing you to transmit more than one message bound together by certain rules. So the large chunk of data can be transmitted by these means. There is also emergency protocol, which is used in there, which could give you an information how there's things working in CANopen network. And if there are some errors occurred in a network in any device, the device, if this supports emergency, because it's optional service, can submit this message and inform all participants in the network, especially Lift host controller, what is going on in there, and provide some detailed information. So the network management stuff allows you to monitor error conditions in the device, different than emergency about errors in process, whatever, but the problems with the device itself. For example, I could detect if the device is on bus and it is operating. For that reason, we use error control protocols, and boot up is used to register the device in the network. At the very first moment, the whole network is started up by the host controller, which is a Lift controller. There are a few other protocols like synchronization timestamp can be used as well. You could read more exactly on about them in SIA 301 specification. Just few slides about these services. Service data object is done, is confirmed point-to-point communication, and we require two messages, one for requesting the data or submitting the data, and another for confirmation. So it needs more than one message as the PDO, but it is used for configuration if you need to confirm your data. For the case you design a system where you need to access between devices and access not only devices from your Lift controller, as in a Lift, but to communicate between the devices, you would need to assign another STO communication pair. So you need another STO client server communication. This is how you do this. The process data object transmitted in a broadcast, very effective way, transmitted only process data. And you can collect this data using RTR as well. So it is possible, but should be taken care of the occurring flow of this one, which is mentioned at the very beginning. So in the Lift, another PDO variation is used, which is actually a mix of PDO and MPDO. So you can transmit more than 8 bytes of data, but you need several messages for that. In one message, you could transmit at maximum 32 bits of data, but you could transmit up to 254 messages, whatever process data you need, you can do this multiplexed PDO protocol. So I go very quickly about this emergency and other stuff because we have to finalize some point this presentation. Emergency structure can be found in CA 0301. Especially it is used in CANopen Lift specification, CA 470, where the manufacturer specific bytes, where you can see this here, MEF, is used in a standardized way. So basically, unfortunately, you cannot use this manufacturer specific way. You have to take care if your manufacturer's data is not already used otherwise in this specification. Beside that, you have error codes where you could indicate any kind of errors. NER is the error register, and actually the error state machine of your device or component could give you with a bit 0 in object 1000 information, either device is an error, and this message is broadcasted throughout the CANopen network. With NMT, you could start, stop, monitor the device and transit them into certain communication state machine of CANopen. Very effective way. Boot up protocol, every device, even a lift controller of self-starting should register themselves in the network after they go into pre-operation with this message. With a heartbeat, I monitor the state of the device, and in a given state, I could reset the whole network back to its original state and reconfigure this if it is necessary in case of the heartbeat errors. So there are some advanced protocol we could look into. This is layer setting services. By this means, I can configure my network, especially this device address of each single component. Then I could switch the existing bitrate to another one. We have certain NMT master capability, which is called NMT, actually CANopen Manager, which is resided typically in lift controller, lift host controller. There is also possibility if I have several lift applications working into one, or lift group, or group lift as it's called, with multiple shafts, I need to switch between the masters in the system. So I need effective way to do so. It's called flying master protocol. You could read it more exact in specification 302. There are CANopen application and device profiles, which is available everywhere and for every designer. The device design is actually unconfigured devices. That doesn't apply for CANopen Lift. CANopen Lift is actual application profile. So you have to take care of that. To know this, device profile has more standardized ways to approach. You can exchange the devices, but they are not configured. You have to configure these devices if you design them for the specific reasons. In CANopen Lift, however, we call it application profile. Such devices, like you see in a device profile, already pre-configured within this network. All PDOs pre-configured for the reasons. All CAN identifier already configured for this one. So basically, ideally, you could purchase this one from the shelf and stick into your network, and it should be operating at the very moment. CANopen offers some testing as well, which applies actually more for devices, but you could test your compliance to CANopen basically. But more effective will be for CANopen Lift, since it's application and it's already configured. The CANopen conformance is for unconfigured devices. Then this one is stick all devices into network, check if under dynamic conditions they operate in, for example, a lift network. So we do had or have in twice a year doing CANopen Lift Plug Fest. But due to COVID-19 pandemic, recently it's become a little bit difficult to do so. But I think when it is all somehow goes away, hopefully someday we will again do the plug fest. We could do very effectively test the components for their interoperability and compatibility to each other. There are, of course, things where you could design your device and you could provide the old information in so-called file formats called EDS for generic and DCR for pre-configured a list of parameters and information from your device. Just for your information, you could configure with special tools using the EDS and DCR file. Also in the Lift network, you configure your whole network in there. So I'm closing to the finalizing of my introduction. I just wanted to point out there are plenty of CANopen specification available in general for various CANopen device and application profiles, various protocols and interfaces used in CANopen. CR417 series is for application profile for Lift, where you can find everything you need for Lift in there. And there are a lot of more for in general for CANopen. And here I compiled the specification, especially interesting for the Lift. So where you could find all the information you needed if you start designing Lift application, or even if you designed or maybe forgotten or looking for their specification, gives you more details on how to do so. CANopen is also standardized, although CANopen Lift is not yet, we have not decided about this in a group. There are other standards for CAN data link layer, CANopen profiles, for subsea, for drive controllers. So CANopen is a flexible and standardized framework which is used in various application areas. So that is all I wanted to give you as a short overview. Thank you very much for hearing me.